Welcome, and in this video we're going to continue looking at rational functions, and specifically now after finding the domain, the next thing we want to do is look for vertical asymptotes and holes. And so let's begin with vertical asymptotes. All a vertical asymptote is a vertical line that, and I'm going to draw a dash, and then, okay, I missed the mark. Okay, we'll put a mark there. And so this would be a value c, and so this is a vertical line x is equal to c. That the function gets really, really close to, but never actually touches. So we would see something like this and like this for f of x. Okay. Now keep in mind it can do either way. So it can increase or decrease without bound. It could increase on both sides. That is perfectly okay. It could increase on one and decrease on the other, something like this. So this is a different variation, and any combination thereof. Okay, so that's the idea of a vertical asymptote, is we should see this behavior near it, and it actually never touches or crosses. A hole, on the other hand, is precisely what it sounds like. It is a hole. Okay, so if you can imagine, there's just a comma r of a value, and we'll explain what this is in a moment. But there's a literal hole in the graph because what we would see is the function would have every value except that on both sides of it. Okay, and it would just continue something like this. Okay, now the idea is r of a is called the reduced form, so it actually isn't. So we start with our original function, and then we have to do some algebra on it. Things happen, and we get a reduced form. What we would see is in the reduced form, it would not present a problem. It would have a value, but it's not defined in the original function before we did all the algebra. Okay, so that's a little confusing. We'll see an example here. Now, how do you determine which is which? That's the next question. So this is kind of a flowchart that I highly recommend getting in your notes, and it's going to begin with my favorite F word, factor. Okay, after you factor, you're going to find the domain for f of x. Okay, domain f of x. Write it down. Got it. Okay, moving on. Simplify. Okay, and when I say simplify, cancel factors as needed, and then you're going to get the reduced form. Okay, so let's just say here that we found the domain was everything but 2 and 3. Okay, moving on. Then after we do the reduced form, we're going to find the domain again. And maybe this time we just get x cannot be 2. Okay, this is a theoretical example. Okay, then after this we have two things we can do. We can look at the restricted or the reduced form of r of x and say that those are the VAs. So we would have a VA in my fictitious example here at x is equal to 3. Then, or sorry, 2. I meant 2. Okay, then if we notice that 3 was a restricted value in f but not in r, that's actually the location of a hole. So I would have a hole at 3 and then whatever r of 3 produces. Okay, and boom, there we go. Okay, so we're going to work through this example here quickly. I'm going to go through my flowchart. So first thing, factor. Okay, x squared minus, let's factor it right away. X minus 2, x plus 2 over x, and then 2 minus x. Okay, and actually it will be useful for us to do just a little bit more in the denominator. So I'm going to take out a negative, which causes the x and the 2 to reverse signs. Okay, now again, don't cancel because I have to, before I simplify, right, I need to look at the domain. Okay, so I'm going to say the domain here, or domain, let's say domain of f is all real numbers except, now what makes the denominator 0? So 0 and 2. Okay, great. Moving on. Now is when I'm going to look at simplifying this thing. So I cancel the x minus 2's, and I'm left with x plus 2 over negative x, and this happens to be this reduced form. Okay, there are instances where the function and the reduced form are the same. That can happen. Okay, so great. Moving on. Look at the domain of this. Domain of r is going to be all real numbers except 0. Okay, great. Moving on. Got that one. Now I need to look at VAs and holes. So I'm going to have, let's see, here's an A, here's a V. x. Okay, so here's VAs and here's holes. Okay, now according to this flowchart, any restricted values of R are vertical asymptotes. So that means I have a vertical asymptote at x is equal to 0. Okay, now in the original function, 0 is also present, but 2 was also present as a restricted value. So that means that's going to be an x coordinate of a hole. Well, a hole needs an x and a y value, so you just find R of 2. Okay, and so then when you do this, this ends up being 2, negative 2. All right, great. So now what we can do is we can start to make a graph. Okay, and what we're going to see is that, okay, so x is equal to 0 was a vertical asymptote, right? So I'm going to draw a dashed line vertical here, okay, and then also make a hole at, what was it, minus 2, 2 minus 2, so 1, 2, 1, 2, I have a hole there, okay? And what I'm going to see now is, remember on either side of the vertical asymptote, it should rise or fall. So how do I know if it rises or falls? And the answer is, well, let's make a little XY table, and I'm going to look really closely to both sides of that vertical asymptote. And this is called the behavior of the graph on either side. So I'm going to look at maybe like negative 0.01, which is just to the left of the vertical asymptote. And then I'm going to look at 0.01, so positive, which is on the right side. Okay, and I don't necessarily care about the value. I care about what the sign of it is. And I should also mention I'm going to put this into R of x. Is the sign positive or negative? If it's positive, it's going to rise. If it's negative, it's going to fall. And here, if you do some number crunching, you get a minus and a plus. And so that means that when I make my final graph here, I'm sorry, reverse it. This should be plus and this should be minus. Okay, so then when I make my final graph here, it's going to look something like this. So it's going to rise as I go closer to the left side of the vertical asymptote, and it's going to fall, touching the hole, as I get close to the vertical asymptote on the right side. Okay, so that's just a start to the graph. We're going to modify this in future videos, but for now I want you to take a shot at finding the vertical asymptote and holes, if there are any, for this function in a quiz question.